Studies show that chocolate cures depression. Sounds amazing, right? But what if I told you that study only surveyed 12 people over a period of 1 week? It was funded by the chocolate factory and it was never independently reviewed by any experts. Suddenly, it's not so convincing, right? In this video, I'll show you how to separate reliable evidence from clever marketing and avoid being misled. We live in a time when anyone can post anything online and make it sound scientific. Misleading stats, biased reporting, and fake studies spread like wildfire. That's why it's crucial to know how to evaluate sources, to protect yourself from misinformation and make smarter decisions. So let's build your bullshit radar with a simple method called the CRAAP test. CRAAP stands for currency, relevance, authority, accuracy, and purpose. Here's how each part works. Currency. Is the information up to date? See, a 2015 article about COVID vaccines might be outdated, but a 1980 book on French Revolution is still useful because history hasn't changed. Relevance. Does it answer your question? Study on teenage screen time won't be helpful if you're researching adult work burnout. Authority. Who's behind this? A nutrition blog by a random influencer isn't the same as a peer-reviewed study from a Harvard dietitian. Accuracy. Can you check the facts? If a source claims 80% of the people hate their jobs but cites no research, it's a red flag. Look for citations, consistency with other reliable sources, and evidence. Purpose. Why does this exist? An article saying that milk is poison funded by an almond company is most likely to be biased. Ask, is this particular fact here to inform, sell, manipulate, or genuinely help me? Well, let's talk about some red flags and statistics. See, numbers can lie if they're twisted, so we have to watch out for following red flags. Tiny sample sizes. 9 out of 10 doctors recommend might sound impressive, but if only 10 doctors were asked, that's only 9 people and it's not very meaningful. Cherry picking. Showing only the results that support a conclusion while ignoring contradictory evidence is not helpful. Correlation versus causation. Just because two things happen together doesn't mean that one causes the other. For example, ice cream sales and drowning both increase in summer, giving rise to a positive correlation, but that does not mean that one causes the other. Missing context. Cancer rates increased 50%. Sounds scary, but if the case numbers went from 2 to 3, even though the statement is true, it's also misleading. Alright, let's talk about some sources. Sources comes in layers. Primary sources are your OG materials like scientific studies, legal documents, or an interview. Secondary sources explain or analyze the primary ones, like a news article about that study or a textbook. Tertiary sources like a tweet or a meme about that article are even further removed and are more likely to distort the original meaning. Whenever possible, trace the information back to its original source. Quick verification tips. Before believing or sharing anything, look up the author and the site's reputation. If you're looking at a scientific study, check if it's peer-reviewed or not. See if it's already been covered by a trusted fact-checker like Snopes or factcheck.org. Search for other credible sources that are saying the exact same thing. And always ask yourself, would I still believe this if it was saying the opposite? Here's your challenge. Find a bold claim in a news article, video, or a post and run it past the CRAAP test. See what you discover. In the next video, we'll look at the power of asking better questions, a skill every critical thinker needs. So hit subscribe and in the comments, let me know what's the worst source you've seen people trust lately. Let's keep each other sharp.